Yeah, hello everyone. So this is the live session for week 8. Am I audible?
Yes, sir.
Yeah, okay.
Yes, sir.
Yeah, so problems are published and you can start from the live coding problem number 1. So there are 4 problems for today live session. So all problems are based on the complexity. Okay, so in each problem we are asking the efficient solution about log n time complexity. So just start the solution for the first problem. This is the first problem. So in the problem statement, statement said that write a function find peak L that accept a list L of n elements and return the peak elements of the list. A list element is a peak if it is greater than its neighbors. For corner elements, we need to consider only one neighbors. So you have to write the solution of big O log n complexity. So you should consider that there is only one peak in the list. For example, in the sample input, so there are 4 elements, 5, 10, 20, 15. So what is the peak of this list is 20. So you have to find out the peak element in the list in the log n time complexity. So list peak word is used basically. We can also use the max word, but so here like this, if we are draw the curve for the list elements value, so this curve will be like always this form, this form. So this is the peak element. It also can be like this. Last element also can be the peak element. First element also can be the peak element. So this is the type of the list where element can become in the order. So for example, if we have a list, so 1, 2, 3, 4. So there is this is the last element. So only there is one neighbors, which is the less than this element. So this is the peak of the list. Same, we can write this 4, 3, 2, 1. So now this is the peak. So this list represent this diagram. This. Okay, another possibility are like 1, 2, 3, 5, and 4, 3, 2, 1. So this is the peak. So this is the related to this graph. So your function should return the solution in the log n complexity. When we are talking about the log n complexity, so you can think about the binary search concept in your solution. So in searching, if the log n complexity is asking that, so searching, we know that the binary search is the searching method where we can search the element in log n times. So you can use the concept of binary search in this problem. So just start to write the solution for that. When you completed the solution, just write the message in the chat box. If you have any query regarding problem or regarding logic, then you can ask, but first you should try by yourself. So all participants, you have create participants are there. So all, so you should try to solve. I think the total 4 problems. You should try to solve all 4 problems in within 2 hours. When you completed the solution, then just write the message in chat box. So I received only one message till now. If you are finding any difficulty the problem, you can ask the logic, you can discuss the solution here, but don't stay.
Sir, can we simply do sort and then find the largest one?
No, so we are asking the solution of the log n complexity. When you perform the sorting operation, then it become a n log n. Okay. So for example, you are saying that you are trying to sort first. So there is one list. What is the function name? Okay, df find peak. Okay, so you are sorting the list l dot sort. And dot sort. Then you can return the. It will return the answer, but maybe one test case will fail.
Yes, sir, because one test is not passing actually.
Yeah, because of
That
the
recursion one, yeah.
log n time complexity. Oh, find peak name. Small peak name.
So P caps in find peak.
But in problems you can teach small. Okay. Three out of three passed. Okay, check test. 2 out of 3 pass. Okay. So this is because of the time complexity, basically. What happened if we return the max? So 1 out of 3 pass. Yeah, between one private test case not passing. Yeah, that means your solution complexity is not the order of log n. Yeah.
Yes, sir.
Just think about the binary search, how you can use the binary search concept here. So I'm explaining some logic. For example, if we have a list, so 1, 2, 3, 4, 5, and 4, 3. Okay, so, okay, so 1, 2, 3, 4, 5, 6, 7. Total, there are 8 elements. So we will always so by any such we always check the middle element first. So we can try the concept here. We will check the middle element. So what is the middle element here? So there are total 8 elements. So 8 element by 2. So the middle element is 4. So we will directly check the middle element. So 0, 1, 2, 3, 4, 5, 6, 7. So this is the middle element. When we reach at the middle element, then we will check the neighbors element. Okay. So if neighbors element, so we can check the first previous element, or we can check the next element. If both elements are less than the middle elements, so we can directly return this element. For example, if for example our middle element is so we take one another example, 1, 2, 3, 4, 5, and 4. Okay, so 5, yeah. So here total are there are 1, 2, 3, 4, 5, 6 elements. So we will check first third element, third index element. So 0, 1, 2, 3, 4, 5. Okay, so we will check that third element. So after third element, we will check the previous one and next one. Okay, so previous one is less than the, okay, this is true, but the next one is larger than. When we get the larger one element near to our middle element, so we will skip the left part completely. Okay, we will skip the left part and then check the right part only using the binary search. So now in right part, we will check again what is the middle element here. So what is the middle element is 5. Then we will check the previous one and check the last one, next one. So if anytime this condition is true, neighbors condition is true, so we can return the middle elements also. But we have to take some constraints. If our element is the if our middle element is at the first position or the last position, so we have to check only one neighbors in that case. So you can use this concept.
Yeah, but supposing, sir, what I was just want to say, supposing you have a list like 163, 454, let us say.
1 second.
So
1, 6,
163, 454.
4, 5, 4. This means so
Yes, sir.
actually our solution said that what is the peak element is. Peak element is when the neighbors are smaller than the element. Okay, so in this list there are two, we can say that there are two peak elements. So there is 1, 6, and we can say that this is also a peak. So but problem statement
So
6,
we don't have to find the absolute peak, is it? We just have to find anywhere, wherever it is going beyond this thing. Is it like that?
no, so in problem statement it is said that consider that there is only one peak is in the list. Okay, so more than one peak are not possible in the input list.
Okay,
This
okay.
is the
Understood.
constraint.
Understood. Yeah, yeah. Okay.
Yeah, Harshit, you typed just I. Where are you? Do you want to ask anything? Okay, so how many have finished the first problem? I know one Snehil have completed, and another. Anyone who have finished the problem number one? Bipin. Okay, good. Yeah, so Bipin and Snehil, can you send a solution for problem first in chat box to me? To Bipin, okay. So query is problem number 2. Yeah, find median. Bipin, you can use the same binary search concept also. if you will perform the merging operation, then it become a n. So you have to just try to discard half of the area of searching. Like this in the binary search, we always discard the half of the searching area. So same thing you can use. Code for question. Okay. Snehil. Oh. So yeah, so this is the solution Snehal provided me. So here we are checking, we are using the binary search concept. So we are checking that if the length of the list is 1, then we will directly return the first element of the list. Second is if the length of the list is 2, then we can return the maximum element of the 2 elements. Yeah, so else we will find out the mid position of the list, then check the neighbor condition here. Okay, we will check the neighbor condition. So if our middle element is greater than the both neighbors, previous one and the next one, then we will directly return the middle element. Otherwise, if okay, so yeah, so if our middle element is greater than previous one but less than the next one, okay, so we will call the binary search algorithm on the right part, mid plus 1 position next. Yeah. Else parts we will call the left part. So this okay, this is a nice correct approach. So every time we are discarding the half of the searching area. Yeah, so this is the second problem. Write a function find median a, comma b that accept two sorted lists a and b of the same size, and function returns median of the sorted merged list of the a and b. Okay, so that means median, we will return the median after the merging of these two sorted lists. Okay, but this operation should be performed in log n times. So for example, if this is the sample input, so 1357 and second is 2456. So after merging, what will be the list? So 2 1 2 3 4 5 5 7 8. And what will be the medium? So the medium definition is also given. If length of the sorted merge list is odd, then median is the middle element. And if the length of the sorted merge list is even, then median is the average of two middle elements. So in that case, so there are total 8 elements after merging. So we will check the fourth and fifth position element. So what will be the fourth and fifth position element? So 1 2 3 4. So fourth element is 4 and fifth element is 5. So we will add these and divide it by 2. So 4 plus 5 divided by 2, 4.5. So, but this operation should be performed in log n time. So that means there is no need to perform merge operation here actually. So both lists are sorted. So we can use some concept to discard the partition of the list using some binary search concept.
Sir, do we have to use it? Can we use it like a simple stack and then just find L by 2 and the length of L by 2? Can we create another list and just use it like a stack, Just see the first copy and go on adding, so that you get one
Stack,
first
stack. So what is your logic to find the median using stack?
No, sir, median will be just once you will get your one full list,
One full.
just
So
half of that or whatever, depending
okay,
upon
okay.
the.
So when you perform the operation to push every element into the stack, then it become a n. Okay, so every time you have to read the element and you have to perform the push operation, then it become a n complexity. So same things, we can use the binary search concept here, and we can solve this problem using recursive. So we have to decide the base case. So for example, if we have a list A and B and both have a single element 2, so what will be the median of these elements after
Yeah.
sorting? So we can directly
1.5, yeah.
So if size of the each list is the same always. Okay, so n equal to 1. So both size. So here also n equal to 1. So if size is 1, then we can directly return a 0 plus b0 divided by 2. Okay, same things we can use for the size of 2. So if, for example, if we have a list 1 3 and we have a list second, so 2 4, so then what will be the median? So we can easily find out that, so median equal to max of a0 and b0 comma yeah, max. Okay, this is the max plus min of a1 comma B1 divided by 2. Okay. So what will be the max is in this element 1 and 2. So max is 2. And what will be the minimum is 3 and 4? 3. So this divided by 2. This is 235 and 2.5. So we can use this base as a base case. Okay, when we did not call the recursively our algorithm. If size is more than 2, then you have to decide which part you have to discard. Okay, I'm discussing some logic also. So for example, size is more than 2. So okay, we are taking just sample input 1357248. So for example, if we have a list A 1357 and then B 1, so yeah, 1 2 4 6 2 4 5 8 2 size is more than 2 now, so this is not come under the base case. So in that case we can find out the middle elements. So here we can check the middle elements. So we will take the middle element like this, mid of A. What is the size of mid is 4. So 4 divided by 2, 2. Okay, so 2. Yeah. So we'll check that 2. But in B, mid B, we will take the middle element as so size by size divided by 2 minus 1. So what is the size is 4 divided by 2 minus 1. But there is one condition. No, case was the even. Okay. So yeah. So we always take a middle element, use mid of the A using this formula, size divided by 2. Okay, and we will calculate the middle element of B, M mid. If the number of if the size is even, if the size of the B is even, then we will take mid B as like this formula, size, so size divided by 2 minus 1. If the size of the list is odd, then we will choose simply like mid B equal to size by 2. Okay.
Sir, why we are doing only for B like that and not for A? A also we should have same approach, no, actually.
No, so after merging, for example, maybe in the maybe some possibility is there. So middle element have the equal value. So for example, if we have a list like that, 1 2 3 4. Okay. So here also 4 5 6 7. So in that case, so okay, I'm just explaining completely. So we are, for example, we are choosing that mid A. So what will be the mid A is? So 2. Okay, so this is the mid. Okay, so we will check the, so total number of elements are even. So we will consider that mid is this one. Okay, 5. So size of this divided by 2. 2 minus 1 1. Then we will compare the elements. So which is the less than. So this is for the A. This is for the B. So first we will check if both elements are same, middle elements are same. Then we will directly return the average. So I have to explain the completely. So in that case, okay, so middle of the A is less than middle of the B. So we will discard the larger part here completely. We will discard the larger part. So confused. So once 1, 2, 3, 4, 5, 6, 7, 8. Okay. Yeah. So we will compare the middle element after this finding the middle position. So we will compare the middle element. So this 3 is less than 5. So if this condition is true, that means our median element will always come in this region. 1, 2, 3, 4, and this 4. Okay, so we can discard this part completely. True. So after merging, so these all elements, if our
Sir, yeah, and if it is the other way around, let us say A is greater than this thing, then it will be that it will be in the
then
A
we will
portion.
then we will discard the A portion.
Okay, yeah.
Okay, so we have to take some condition like this. Uh, uh, just try to solve. Otherwise, I explain the solution completely. There will be a 2, 3 condition for the recursive solution. So first condition is that if the middle value are same, then we will directly return the same value. For example, in that case, so this so this is also 5 and this is 8. Okay, so in that case these 5 both middle are same, then we will directly return the this element as a median. So you can see that after merging these two lists, so 1, 2, 5, sorry 4, then 5, then 5, then 6, 7, then 8. So these two elements will come at the middle position. So we can directly return this code. So if A position is equal to B mid B, so we can directly return the element either A mid A or B mid B. So this is also a condition to return the solution. And another case, we have to reduce the searching area. So Snehil, binary search. Sir, can you explain with this respect to the first test case? All the tests and even the private. Somehow only one of the tests will not pass. Okay. So Sunil, what is the complexity of your code? Are you sure that complexity is log n? Okay. Can you send your code? And this is one of A, B. Return expression. Okay. No. So I think this is the simplest solution. You are calculating the medium of both and returning the average directly. But this is not always true. So after merging, median position can be changed of the which you are solving that. So for example, in that case, what is the median of the first test is? How you are returning the median? Okay, well, great. Okay, so what your so 4.25 is returning the answer. And what is the answer? 4.5. So in the for the sample case, your code is not working because after merging, what will be the list according to your solution? So what you are doing is, so what is the value of x and y? We are printing. So 4 and 4.5. Okay. But after merging these two lists, what will be the list? Then 1, 2, 3, 4, 5, 5, and 7, 8. So now what is the medium here? So 4 plus 5. These are two elements in the middle. When we will add these elements, then return the divided by the 2. So answer should be 4. But according to you, you are returning this median part. So 3 plus 5 divided by 2, that is 4. And you are returning the medium this value. So 4 plus 5, so this is 4.9, 4.5. And after that, you are merging these two medium. So this is not always a condition because our sorted list can be in any order, for example. So like that, 1, 3, 3, 3. Okay. And 1, 2, 4, 6. So it is also a possible input. So here what will be your median is 3 from here and here 4.5. So 3 3 plus 4.5, 8.5, then same 4.25 according to your solution. 3.75. Okay, 3 and 4. But after sorting, what will be the list? 1 1 3 3 3 4 5 6. So answer should be 3. The third and some 1 2 3 4 5 B 6 7. Yeah. So Sunil, this is not a correct approach. After merging, so element position can be different. So you are simply finding out the median of each list and then just return the average of both median. But after merging, so median element can be different. So I'm explaining the solution now. Yeah, so find median, we will use another function. So I'm using the median here. So there are two lists, A and B. So because I don't want to use slicing operation in our code, so I'm just using the index in the functions here. Okay, so this first index 0 is representing the start index of A, and this second index is representing the last index of B. Sorry, A. And this 0 is representing the first index of B, and this next index is representing the last index of B. So this is the input for our median function. So after receiving these information, we will calculate the size of the list. So always we will receive the same size of the list A and B. So we can calculate a single time only. For example, this n. So we will calculate the size of the list. After calculating the size of the list, we will calculate that what is the middle position of our list. So we can calculate this middle using this n divided by 2. So because I'm not using the slicing, so I have to maintain the index position in the same list. Okay, so we will calculate the mid of A. So we will add this mid A in the start index of A list. If n percentile 2 equal to 0. Okay, so yeah, this is the case for calculating the middle of B. If the size of the input list is even, so we will calculate the middle of B using this formula SP plus mid minus 1 position before the middle. And if the size of the input list is odd, then we will take the middle as a middle element, middle position element. So we will add simply SB starting index of the B plus mid position. So this is the base case. these are three base case. If n equal to 1, then we will return directly a start index of a. So there is only one element. That means this is the single element on available on the list. So a sa plus b sb, start index of b. We will return the average of these two elements if our size of the list is only 1. If size of the our input list is 2, okay, if we are receiving a and b with the size of 2, then we can directly calculate the maximum of the first element of both lists and plus minimum of the second element of the both list, and divided by 2. So this is the second case we can use as a base case, and this is the third condition. So a mid a. After that, if these two conditions are not satisfied, then we will calculate the middle. We will check the middle element of both lists. So what is the middle element of A and what is the middle element of B? If both are same, then we will directly return the average of both middle element, or we can directly return the middle element as single. So because both are same, so we can directly return the element either of A mid A or B mid B. If this is also not true, then we will check the next condition. If the middle of A is greater than, if the middle of A is greater than middle of B, so we will recursively call the same algorithm where we will skip the part. So you can see that this is the A, this is B, but we will change the index here. So middle of A is greater than middle of B. So we will send the A part as a starting point of for A, and mid A the last point of the. So I'm just explaining here. So for example, in case 1 3 5 7 and 2 4 5 8. Okay, so first we will check the middle, what is the size. So this is the 0 index for 1, this is the 3, and this is also 0, this is 3, our input list. So what is the n value? N value will be 4. So 3 minus 0 plus 1, 4. So we will check the mid of A. So this is S0. So S0, 0 plus, what is the value of mid? Equal to n divided by 2, which is 2. So this will be 2. Mid of A equal to 2. Then mid of B. So mid of B we will calculate by the condition. So if elements of the input list, so we are checking this one. So this is the what, this is value is even or not. So this is even. So we will calculate mid as 0 plus mid minus 1. 2 minus 1. This is one position. After that, we will check the condition. If n equal to 1, so here n equal to 4. So this condition is not true. N equal to 2. This condition is also not true. Then we will move to the third condition, LF. So if A mid A equal to A mid B, so what is the middle of A? So this is this element, and B, this is the second. Okay. So which condition is true? A mid A is greater than A mid B mid B. Yeah. So this condition, this value is greater than this value. So we will discard the area. We will check only mid A. Yeah, so we will check only this part remaining. Okay. So this condition is true. Yeah. So BSA. So SA is 0 and mid B. Okay. We will check this part and mid B. So what is the mid be this SA mid A. So mid is 2. Okay. So we will pass. Yeah, we are passing the index. So we will consider that we will check this part and this part again. So in the recursive call, we will send this as a list. So 1, 3, 5 as A, and then 4, 5, 8. Then we will repeat the same process. We will check the mid element. So the now mid element for the first list is this one, and second is this one. Okay. So we will check then what is the both elements are not same, and n is here is 3. Okay, so mid are not same, but this time b mid is greater than. So second condition will be, so last condition will become true. The mid of the b is greater than. Okay, so we will pass. We will just again recursive. We will use the recursive call. So we will this time we will consider that this part 3 by. Okay, so a b mid a and last. Yeah, this part we will send 3, 5, and here we will send this 4 and 5. Once again, we will check the mid position. So now size is 2. Size become 2. So we can directly return by the base case. So what is the minimum of maximum of first value? 4. And what is the minimum of last value? So 5 and plus 12 by 2. 4.5. So according to this condition, we will get the median of the element. So after second problem, just try to problem number 4, because problem number 3 is also similar like this. So thinking of the solution, it will take time, but problem number 4 you can solve easily. So time complexity for the problem number 4 is n log n, and problem is not too much difficult. Problem number 3 is similar to this one. Same logic you should do. And the size. Yeah. So this is the problem number 4. Write a function picking number a that accept a list a and return the length of the longest set of element where the absolute difference between any two element is less than or equal to 1. So you have to find out the elements which have the absolute difference is 1. So how maximum number are possible in this list? So you have to return the solution in n log n time. So in that case, there are one sample input 465331. So what is the maximum element are available with the absolute difference? 1 is 3, 4, 5. Sorry, 0, 0. Less than or equal to 1.
But I think this will be 3, 4, 4, 5, 5, 6, like this.
3. So there are 4, 3, 3 element meeting the certain criteria.
There are 3 elements in that list where absolute difference between any two elements is.
Okay, start checking the sample test case.
I think, sir, it sort of returns the count. Every time you will count the difference as 1.
Yeah, we are counting the difference. What is this one? So 1, 3, 3, 5, 6, So this difference to, okay, so 3 3 is 0, and then 3 4 is 1, and 4 5 is, so still we will get the 4 value. Longest set, something wrong. It accept a list A and return the length of the longest element where difference between any two elements less than or equal. Just wait, I'm checking the correctness of this also. Okay, just try to solve problem number 3. Then now I'm just checking this one. Anything wrong? Okay, I got it. Yeah, thanks, Pras. Yeah, so question is correct here. So here we are finding out the elements whose difference is less than or equal to 1. So here, so total 6 elements are there. So if we found out the elements, so here 3, 3, and 4, these are elements. So in every pair of these 3 elements, the difference is either 0 or 1. So if we check the difference between 3 or 3, so 1 second, yeah. Yeah, so if we found out the element, so 3, 3, 4 is the solution, because if we found the pair, any pair of these three elements, so 4, 3, 3, 3, and 3, 3, 4, so there are only three combination are available. So in every combination, so the difference of the absolute difference of the elements is either 1 or 0. So you have to find out the elements where the each yeah, so longest set of element where the absolute difference between any two elements is less than or equal to 1. So this is correct, so you can try to write solution for this. So you can start the problem number 4 first. Yeah, Vipin, so complexity for problem number 4, we require the n log n complexity, but the complexity is not set for, time limit is not set for this question. So if you are providing any large complexity solution, then it will get passed. But still try to write the solution with the complexity n log n. So problem number 4, time limit is not set. Have you finished the solution for problem number 4? Bipin? Okay. Okay. I think this is the correct solution. Yeah, pass. Yes, Bipin, so this is the correct solution. Actually, you are performing a dot sort. It will take the n log n time, and after that you are just performing a one n operation using this while loop. So total complexity will be n log n. Yeah, this is the correct approach. So problem number 4. Yes, I should not the while have a worst case time of n square. So Sunil, so while actually we are increasing this size right and left every time one. Okay. So this is the condition for breaking this while loop. If the left is less than plan of A and right is less than plan of A. So we will reach this condition. I think we will take the n time. So how you consider the log n square is will become. So there is no nested loop here. Yeah, so approach for the problem number 4 is simple. We will sort the element first. So sorting algorithm will take the n log n times. So 1, 3, 3, 4, 5, 6. Okay, after sorting the element, we will start from the first element. So we will consider that what we will fix the one position. For example, we are fixing that at the first element, and we will start from the second element. Okay, so for example, our index is I. We will start from the second element, and we will check the difference between this ith element and the POS element. So if the difference is more than 1, so we will change the position to the I and repeat the process again. So in that case, first POS at the first position with the element 1, and we are checking from the 3. So difference of the 3 is 1, 3 and 1 is 2. Okay, so this condition is not true. We require the absolute difference 1 or 0, 1 or less. So in that case, if the condition is not true, then we will shift this POS location to I. So what is the I is currently? I also index is 0, 1, 2, 3, 4, 5. Okay, and same time we will set one counter, for example max equal to 0. We are initialized, so we will check that. So I is now the difference between POS and I is not less than or equal to 1. It is greater than. So we will shift this position location now POS, and we will move to the I to the next element. Okay, now we'll check again. So I is 3, and check the difference between here. So 3 difference is 0. Yes, so this is the true condition. So we will increase this max counter now at this case. So we will increase this max counter, it become a 1. Every time if we receive the counter value, so we have to take 2 actually. One is max and one is counter, and we will increase the counter and compare with the max. So initialize, we are initialize the max equal to 0 and counter equal to 0. So in that case, so we will increase the counter 1, then move to the I value to the next element, where we will not shift the POS value. We will shift the POS value in that case when the difference is more than 1. So now in that case the counter become 1. Now we will move to the I here. So now ith element is 4 and the POS element is 3. So difference is 1. Okay. Okay, so we have to start the counter from 1. Okay. So now counter become 2 in the previous case. Now when this 4 is difference between 3 and 4 is 1, so we will increase once again. Now counter 3, and so after that we will increase this I next, and I this here POS at the same place. So we will compare this 5 and 3. So the difference is more than 1. So in that case we will shift the position POS. So POS will be moved to the here. Okay, and we will check that what is the counter value, and counter value is the greater than max, then we will assign the max value as a counter. So max is 0, counter equal to 3 now. So we will set that max equal to 3. Then we will check again. So what is the difference between I here? So 6, and set the counter once again to the 1. In that case, counter we will repeat from the 1 again. So now I6, the difference between 6 and 5 is 1. So we will increase the counter by 1. So counter will once again start from 1, then 2. So after that list is completed, so we'll check once again the counter value is greater than the max or less than max. So this is less than max, so we will return the max answer as a solution. So here complexity is only written by the sorting function and login. So after that we are performing, we can perform this solution in a order of n time. So total complexity for this solution will be n log n. So this is also a similar type of a solution for problem number 4. So after assigning this value, we will just use one loop from range from 1 to length of the a last element. Every time we will check the absolute difference between ai and pos. If it is less than or equal to 1, then we will increase the counter value. Else, then we will check the count to the max. If counter is greater than max, then assign the max equal to count and reset the counter equal to 1 and change the position to I. So if the difference is more than 1, then we will set the this all completion. So after completion of this loop, we will check the if max is greater than count, then return the max, or else return the count. So this is the in order solution, and this sort function will take the n log n time. So after this, only problem number 3 is remaining. So write a function kth element a, comma b, comma k. So here a and b are list to sorted list of the size n and m. So size of the a and b can be different here, and here we are also accepting a one argument k, and function return kth element in the sorted merge list of a and b from start. That is solution of order log n plus log m. So same thing we have already done in the previous question. So after merging, after merging sorted list, so what will be the kth element? So after, for example, in sample input, so 1, 2, 3, 4, 5, 5, 7, 8. So this will be the sorted list after merging. Then 1, 2, 3, third, we are asking for the third element. So third element is 3. So, but this this solution should be written in the log n plus log m time. Yeah, so this is the base case for the problem number 3. And after that, the remaining part, you have to decide that how you can reduce the problem into this best case. Sorry, into this base case. So here, this is the condition. If n equal to 1 or m equal to 1, that means if the size of the any input list is 1, either of a or either of array 1 or either of array 2. Okay, so we can return the kth element like in this manner. Okay, so this is the first case. If the size of the m equal to 1, then we will swap the naming of the list, both lists. So we will assign that ARR2. Just I mentioned that L just A. Yeah. So here we are receiving the list as input. For example, the A list is have the 4 element and B list have the 1 element here. This is the size for the both list. This is 4 in A and 1 in B. And I went tested to find out the third element after merging these two lists. So we can check that if n equal to 1 or m equal to 1, and any of the list size is 1, then we will check that if m equal to 1. So this step we are using to reduce the our code. Otherwise, we can use these next 3 lines 2 times for both, if m equal to 1 or n equal to 1. So after renaming, we are using the same code. So if m equal to 1, so we are just reversing the naming of the list and assigning that m equal to n. So after that, we will check this condition. So for the simplicity, just we are checking this, converting this element x4, this one. Okay. So now this is 1, this is 4. Answer will remain the same. Yeah. So here n equal to 1 now. Okay, so we are skipping this step. Now check that if k equal to 1. So here what is the case? 3. So if k equal to 1, then we will directly return the minimum value of a0 and b0, because we know that the b0 have the single element. So we will compare the our first element of the a by the first element of the only single element of the b. Maybe some possibility, then the first single element of b is maybe less than the first element of the a. So we have to check this condition because we are finding out the first position element. So we will return the minimum of a0 and b0 here. And if k equal to m plus 1, so what is the m here? So m is here is 4. Okay, so m is the size of the second list. So if k equal to m plus 1, that means m 4 plus 1 is 5. So for example, k equal to 5, then we will directly return the a0 m plus 1. Okay. So n plus 1, so that's n equal to 1, 4, suppose no 5. So what is the max of, okay, so this is 4. What this is not, it's also n equal to 1, n equal to 4. If this condition is true, then if k equal to n plus 1, so n is here. Oh, so percent 5. This is not a correct. X. So condition is yep. Okay, so this condition is not correct. Yeah. Jump k equal to 5. So k equal to 1. K equal to 5. K equal to n plus 1. N is 4. So 4 plus 1, 5. 5. Max of a0. A0. So this is 2. Not a true condition. Okay. This one. Still 4. A0. This is 1. Okay. Equal to n plus 1. Equal to 1. Okay, so we have to some modify this. So here the condition is if k equal to 1, then we'll directly return the minimum of a0 and b0. If k equal to n plus 1, that means second position. So we will return the maximum of a0 and b0. So otherwise, if k is more than k is another than 1 and this 2. So we have to check this condition b k minus 1. What is the b k minus 1? For example, if we have a third, so our solution is returning 4. So after merging 1, 3, 4, okay, correct. So this is 5. It puts 1, 3, 5, 1, 3, 4, 5, 7. Just on page 7. bk minus 1 is less than a0. K square k minus 4 a0. In that case, this is the index present. Oh. Fourth element, so fourth, why is not returning? Check this, and plus 1, and this is the plus 5. Okay, so this is this before this will be the here. Okay. Okay. Yeah, so this is the condition actually. So this is the single element list A, this is the 4 element list B, and this is the size of the both list, and this is the kth position. We are returning the solution. So this is the base case actually if n equal to 1 or m equal to 1. Okay, so we are not using this for a given input. So because m equal to 1, this condition is not true for this. So if k equal to 1, so okay, we are taking k equal to 1, then that means we are interested to only first position element. So we will compare the first element of both lists. So this is only have a one element, and this is the first element. So we'll compare these. So we will return the minimum of these 1 and 4. Otherwise, the second condition is that if the k value is m plus 1, that means the total element is 4 plus 1 is 5. So if k equal to 5, that it value is representing that m is here is 4, 4 plus 1 is 5. So if k equal to 5, then we will return the maximum of a0. This is the single element. That means we are comparing the last element of B and the only single element of A. So which is max, then we will return that. Okay, so here k equal to m plus 1. Then we will return the a0. We will return the maximum of a0 and bm minus 1. So after merging this two sorted lists, so what will be the fifth element will be 1, 3, 4, 5, 7. So maximum of the 4 and 7 is 7. So we will return the seventh element as a fifth element. And the another case, so we will check this condition. So if b k minus n, for example, if we are taking 3, so b of k minus 1, so 3 minus 1, k is 3, 3 minus 1 is 2, so b2, we are comparing the element of b2. So b2 element is this 5 is less than a0. If this element third element is less than the 4, so this condition is not true. So we will move to the else part, max of the a0 and bk minus 2. So bk minus 2 is 3 minus 2 is 1. So we will return the maximum of 3 and 4. So that means so total that means if this 4 is less than 5, so after merging this 4 will come before this 5. Okay, so we will return the maximum of 4 and this 3. So because of that, which position it will come after the merging, so 4 will come after the 3 because it is greater than the 3. So because of that, we are returning the maximum of a0 and this 3 one by this condition. So this is the base case for the problem number 3, and our work is how we can reduce the problem to this base case. So after this base case, so you have to find out the you have to compare the middle element of each list A and B, and decided the recursive call, and what area you have to discard it for the searching. So you have to come on this base case after each recursive call. So reduce the size of either A or B list and come to this base case. When you reach this base case, return the solution directly. Yeah, so without calling again. Yes, Neil. So approach is approach same, but some recursive call is tricky. Which part you have to remove for the recursive call? So this is the main part of this problem. It will take some time to decide. So this is the base case. You can remember this base case. According to this base case, you can decide how you can reduce the size of searching in each A and B. We just try to solve this fourth problem. So maybe some better solution you can solve. So if you have any query regarding these problems, so I'm not disclose the solution of fourth problem. So just give some time for this problem number 3. So another plus we have already discussed solution. Just give some time for this fourth problem. If you faced any difficulty to next week, so we will discuss in the next week the complete solution. Any query? So one of the list must be of the length 1. So no, this is not the condition of the problem. Actually, I am there. I am showing the base case of the recursive function, because every recursive function has some base case for terminate. So here I explained the base case for this problem, where you did not call again, where you will not call again this function. So in each recursive call, you have to call the function recursively by reducing the size of the problem. So using this base case, you can decide that how you can come to this reduced part. Problem statement is that the size of the list can be anything. For A and B, it may be same, it may be different. Any other query? Okay, so we are I'm closing the session. Just keep practice with the problems. If you have no query, then I'm closing. Okay, bye everyone.
Thank you, sir.
Okay.